discuss this particular problem that came in JE 2000, and this problem is look like easy, but many they commit mistake here. And the second question that we are going to take, this is the specific problem that came in 1999, and these two problems look like easy, but once you start attempting, so you feel the complexity. So let's go one by one. So this particular question, what the basic idea about the question? They have oriented these four charges in the respective places, and the one charge has released from infinity, and the question situation is when this charge will going to reach to the origin, what will be the situation, under what condition it will reach to the origin, when once it reach to the origin, what will be the velocity. So this is the situation they have asked. So when the particle is moving along the x-axis, of course from infinity it will going to pull by some electric field, but here you can see the respective charges plus and minus both are there. So one charge will attract and other charge will repel. So along the line there is some point what will happen where the electric field value will be 0. By this way we can able to see if this charge is going to be retarded gradually. Correct? Why it is retarded? Because plus and minus both charge are there. Plus will going to push and minus will going to pull. So resultant force will be 0 anywhere along the line. If we calculated that particular point, so what will happen? We are successfully say this particle cross that particular point, so of course it will reach to the origin. So this is the only idea about the question. Those they got the idea about this particular question, I thought they can able to successfully solve the question. I repeat once again, plus minus, what is the role of it? Plus, let's say this particle is also plus, so it will going to repel, but at the same time minus will attract. We can say resultant force acting on it. So once we calculate, how to calculate the force? First we calculate the electric field. So here electric field value E1 and E2 will be acting along the given line, and I have considered the angle respectively alpha and beta. So which component it will going to become along this along the x-axis, that is cos alpha and cos beta. So the value of E we can say kq by, this is plus 8 coulomb. So plus 8 coulomb will apply the electric field along this direction, and electric field via plus 8 coulomb will be just opposite direction. Once you take the component, you will get the resultant electric field along the x-axis, and of course it is positive direction. At the same time, negative charge will going to pull the charge towards the origin. So there is some point where the resultant electric field will be 0. This is what our point of consideration. Once we get that point where the electric field is 0, so we can say the force will be also 0. The force will be also 0 means that point the particle is about to stop. If we search that point, so our role is very easy afterward. Once we consider electric field to here, once we make both electric field equal, so we'll get the value of x. Once we get the value of x, what we supposed to do? Next intention is we have to calculate the work energy. Why? Because we have to calculate the velocity. So for velocity, we already knowing. For calculation of x, we can calculate the potential at that point, and potential at infinity will be 0. So by using the simple work energy, so work energy theorem, potential at infinity, kinetic energy at infinity, that will be potential energy at P, kinetic energy at P. So potential at infinity is 0, kinetic energy they have given in the question half mv naught square, and that should be equal to potential at P. And how to calculate potential energy at P? Potential energy means potential we have already calculated, multiply by Q. So we will going to get the potential at point P. And the kinetic energy, this is a limiting condition, we can say 0, sir. Once kinetic energy is 0, so this is the velocity, minimum velocity. Why the kinetic energy 0? Let's say kinetic energy is somewhat not equal to 0. This velocity is not supposed to be minimum. Because if we have given more than this velocity, what will happen? It will cross that point and it will reach to the origin. Are you getting? Are you getting or not?
Yes, sir.
Okay. So regarding the given concept, if you have any doubt, because this is a very specific key concept, we can say gravitation as well, we have used the same concept, minimum, so it will reach to the planet, minimum, so it will reach to the point. So I thought you have understood. It's better to cross check only the variety, like plus and minus both charge are there. So you at once start thinking about something is fishy here. We have to not calculate exactly at origin, but somewhere where the resultant electric field is zero. Resultant field is zero means what? Resultant field is zero means the force will be zero. Force will be zero means particle will going to stop there. Force means zero means two meaning. Either it will stop or moving with constant velocity. We can say this is not the case. It will just going to be moving after this point. This is the second condition. It will going to stop. If we have given the velocity more than this velocity, what will happen? It will going to, if it is going to cross this point, it will reach to the origin. That's why they have used the word minimum, least value of V naught. Listen, these words, if you start catching up, minimum, least, other now you can correct very easily. If the velocity is more than this V naught, what will happen? It will going to reach. Otherwise. So I thought you have understood this particular problem. Anybody has any doubt, they can ask. Otherwise, we can move to the, we'll move to the next problem. Okay? Okay. Okay, fine. Anybody has any doubt? Any doubt?
No, sir.